Hey there, statisticians. This is Mr. Gilbertson again from Independence High School in Glendale, Arizona. So what we're going to do in this video in 8.2, we're going to start talking about our proportions. Remember, proportion is P, parts over whole. So when we are constructing a confidence interval about a proportion, we need to meet a couple conditions. First off, we need to be random. So the data comes from a random sample from our population, and we need to meet the 10% condition. When we're sampling without replacement, our sample size has to be less than 10% of the population. So the 10% condition says sample size is less than 10% of the population. And again, this is true in most conditions, but we need to double check, especially if we're given counts. We have to have our large counts where we are saying n times p hat and n times 1 minus p hat are both at least 10. So the sample size times the probability of success and the sample size times the probability of failure needs to be at least 10. The number of successes and the number of failures have to be both at least 10. Why do we care about these? Well, if we have a random sample, when our sample is random, we can make an inference about the population from that sample. So knowing a little bit about the whole group lets me then conclude about the whole group. My individual observations can be treated as independent if we meet the 10% condition. And this is important because the 10% condition introduces chance into my data production process. The 10% condition allows us to calculate our standard deviation as well. I'm trying to scroll down. Why is it not? So the 10% condition allows us to calculate standard deviation. Now, we can see standard deviation of a proportion written in two separate ways. This is the one we used in Chapter 7, but now we're going to call it our standard error. Now, in our formula sheet, we're not going to see it saying SE for standard error. We're just going to see, oops, let me do that again. Let me do a pencil. We are going to see S sub P hat equals this. This is what's on our formula sheet. And lastly, again, when our large count conditions are met, we can use a normal distribution to calculate our z-score, our critical value. Alrighty, what that means, that would look like this. So remember, a normal distribution is going to be a normal curve. Oh, that's just awful. Let's try it again. So I'm going to give you a normal curve, and what we're going to find is we're going to have a negative z asterisk here, a positive critical value there, and we are going to be C% in between. So that is going to be important because of the large counts condition. I already used this word, standard error. So when the standard deviation of a statistic is estimated from data, that result is called the standard error of the statistic. And again, my formula sheet is not going to say standard error of p hat. It's going to say S sub p hat equals p hat times 1 minus p hat all over n, and we take the square root of that whole thing. So how are we going to do this? So when conditions are met, when we meet those conditions, the large count condition, random samples, 10% rule, we can create our confidence interval using this formula. P hat, that's my point estimate, plus or minus the critical value of z times the standard error. Okay? So what happens if we can't meet all of our conditions? Well, if I can't meet all of my conditions, it depends what happens depends on which one is violated. So if we are not random, we will limit our ability to make an inference beyond the sample. I cannot make an inference about the population. So we can't use p hat to infer p. P hat comes from my sample, p is the population. If I violate the large count condition, the capture rate will be less than the one specified by the confidence interval. So if I want a 90, let's say I want a 95% confidence level, what this means is less than 95% of confidence interval will capture P, my parameter. And when I violate the 10% condition, if I don't meet the 10% condition, if I violate it, means that we are sampling a large proportion without replacement. So the formula we use for the standard deviation of p hat gives a value that is too large. So my standard deviation of p hat will be too large when that 10% is ruled broken. That is going to make my confidence intervals wider than they needed. All right, so we're going to take a pause here before we go on to the next video. In assignment 8.2, we are now going to answer exercises 1 through 10, and I'll see you in a hot minute.